All right, so today what we're going to do is we're going to talk a little bit about inequalities. Now, inequalities have less than, greater than, less than or equal to, or greater than or equal to signs. So when you're seeing an inequality, it's set up a lot like an equation, except for instead of an equal sign, you have one of these. Okay, that's what you're going to be looking for whenever you have an inequality versus an equation. Now, equations normally, they have one answer. They can have infinite solutions or no solutions, but normally you're looking for that one solution when you're dealing with an equation. An inequality often has multiple solutions. Okay? It can have no solution, but inequalities, you're looking at multiple solutions here. Because anything, when you have the less than, anything that is less than that number is an answer for your inequality. Where if you have the greater than, anything that's greater than that number is a solution to that to that problem. Okay? And the same thing for less than or equal to. Anything that has a little line underneath there, that's equal to. Okay? And greater than, same thing. Okay? So what you're looking for is this inequalities, and we're going to try and solve them, but then we're going to also graph them. And we're going to graph them on a number line. So where you saw an equation, it was graphed on a number line, it just had the little dot on there. An inequality, you're going to put the dot on there or an open circle, and you're going to point which way actually solves this inequality. So we're going to solve them, and we're going to solve these inequalities just like we would an equation. So we spent all this time on equations, and now we're switching to inequalities, but you solve them the same way. The steps are the same. Okay, so here we have x plus 2 is greater than 4. And I'm going to do the exact same thing I did in a one-step equation. I'm going to draw my line, just like I did before. And then I'm going to go and see what's happening here. I'm going to add my inverse here. Add -2 to both sides. Okay? This is going to cancel out. And then I'm going to bring down the x. And then I'm going to bring down my inequality here. It's the same thing, where before we were bringing down the equal sign, I'm going to bring down my inequality. And then here, I'm going to find out what's left on this side. 4 plus -2 gets me 2. And then here, I'm going to take this, and I'm going to graph it along here. Okay? That's what we're looking for. So we have to read this and understand what's going on. X is greater than 2. Okay, so here's our number line, and what I do is I make this as simple as possible. Okay, whatever this number is goes right there, 2, and I'm going to start right there. Okay, 2, 3, 4, 2, 1, 0. Okay, remember to the right, the number gets bigger. To the left, the number gets smaller. Okay, key on when you're graphing these things. And then I'm going to look back at this inequality. Well, that's greater than. Well, it doesn't include this 2, so it's going to be an open circle. So here, we're going to start right there, and then anything that is greater than 2 is a solution to this problem. So here, anything to the right of this is a solution for this problem. And you can check it. Just put in one of these numbers, and if it's a true statement, you got a good answer. If I put 2 in there, is 2 greater than 2? No, it's equal to. But if I put 3 in there, is 3 greater than 2? Yep. So now I have this good solution here. Okay? Well, we're going to come over here and we're going to do the same thing. All right? Solve it. Again, draw our line. Okay? Just because it's on this side doesn't change anything. We're still going to solve this the same way, just like we do in an equation. Add the inverse. What I do to one side, I do to the other. Add the inverse. Cancel this out. X. Here. 4 plus -2 comes 2. But now we got to graph off of this. I do not graph off of this. Okay? When I see this, I think graphing from here is a little bit more difficult. What I'm going to do is I'm going to take these two things and I'm going to switch them. Once I have it solved, wherever my x my x. If it's on the right hand side, I'm going to switch it with what's on the left hand side. So I'm going to switch x and 2. But when I do that, I have to flip the inequality. So here it is less than. I'm going to switch it, and it becomes greater than. It's still, if you know the whole alligator thing, it's still trying to eat the number that it was before. So if you've seen that, that's what is happening. It's still the same thing. So when I switch it, it makes it a little bit easier. Now, there's also a trick to this also. Okay, x is greater than 2. If you draw a little arrow right there, that thing tells you which way to point your arrow on your number line. Okay, so that's one of the reasons that I do this, is because when I do this, it makes it where it's really easy to tell which way to point your arrow. If you did that here, it wouldn't work. You would be pointing the arrow the wrong way. Okay, so this only works, this trick right here only works when the variable's on the left and your numbers are on the right. Okay, so only use that then. But then I'm going to take this and I'm going to graph it. But when I do, notice it graphs out the same here. Okay, this number ended up being the same here. I mean, I did that on purpose, but I wanted you to see how when things are over here, it can turn out to be the same. Okay, so there we go. There's that one. So we're going to keep moving. Even though it's a subtraction, doesn't change anything. It's all the same. Okay, draw your line. That goes with that. Remember, sign goes with the number. Okay, add its inverse, add its inverse. These cancel out, and you have x is greater than 6. Bring that down. Okay, my variable's on the left. That's exactly where I want it to be. So now I can graph this. Oh, it's still going to the right. So here, x is greater than 6. I'm going to make this 6, 7, 8, 5, 4, and then open or close. No line underneath it. Open. Okay, my arrow is going to the right. Arrow to the right. Okay. Do not overcomplicate this. Okay, don't overcomplicate it. It's pretty straightforward. All right, same thing here. And again, I set it up the same way, where you have the x on one side here, then you have the x on the other. I want you to get comfortable doing this. Okay, draw your line. Add the inverse. These cancel out. Bring down your variable. Bring down your inequality. Put these together. But now, my variable's on my right-hand side. I want it on the left. I'm going to switch it. X, 6. And what I do, I flip that inequality. X is greater than 6. Just makes it easier to graph. That's all it does. Okay? That's the only reason I do this right here, is because it makes it easier to graph. Okay? All right. But it's the same stuff. Now we're going to move on to here. So now we didn't have a line underneath there. Now we have a line under here. Okay? But it's the same setup. Draw your line. Add the inverse. They cancel out. And x, I bring down the inequality. And when I bring that inequality down, less than or equal to, and then I bring this down. 4 plus -2 gets me 2. And then I set up my graphing here. Okay? I believe that we can do the solving of the inequality. It's the graphing I want to make sure that you have down. Okay? Because we spent a whole bunch of time on equations. I believe we can do this part. All right, so now we're going to graph. Well, I'm going to start with whatever number's right here just to make it easier. So 2. All right? If that was a -2, I'd make it a -2. Okay? And then remember, my arrow's going to be going this way. But now, because I have this line in here, under here, it's saying x is greater than or equal to. So this right here, instead of having that open circle, well, it does include that number. So I'm going to put a closed circle there. Right? Because it could be that number. And then to the right, and we're good to go. All right? Now again, if I want to check, does 2 go in there? Yeah, and see, I should have put my numbers here, just to make sure that everybody understands what's going on. Okay? If I plug 2 in there, does it satisfy this? 2 is greater than or equal to 2? Well, yeah, it's equal to. If I plug 3 in there, 3 is greater than or equal to 2? Yeah, it's greater than. But if I plug this 1 in there, 1 is greater than or equal to 2? No, it's less than. Right? That's what you're looking at. Right? I mean, it's pretty straightforward. It's not difficult. Just watch and be careful. Okay? Same thing here. Draw the line. Add the inverse. They cancel out. X is less than or equal to 2. All right, again, 2, 3, 4, 1, and 0. But now, look at which way my arrow's pointing. It's going that way. Okay. Does it include this? Yes, because it has the line underneath it, so it's including this number. Okay. But instead of being greater than, it's less than. It's less than. And that, I mean, that's all there is to that. Okay, be careful when you're doing negative numbers through here. And I think, yeah, I'll have a couple here in a minute and we'll watch and see how it's graphed, but be careful with the negative numbers. All right, so that's add, subtract. Now we're looking at multiplication and division. So there's a rule for this, but right now we're just doing with positive numbers. We'll deal with the rule here in just a second. So draw our line, just like we do an equation. This is multiplication. The opposite of multiplication is division. So in order to undo multiplication, we divide. So we're going to divide by 2. Divide by 2. This cancels out. And x, bring down my inequality. 4 divided by 2, 2. Going to graph it. 2, 3, 4, 1, 0. Open circle, because there's no line underneath there. And then, oh, my arrow goes this way. My arrow goes that way. Okay. All right. Division. X divided by 2, less than or equal to 4. Okay. In order to undo division, you multiply. Multiply by that bottom number. Multiply by that bottom number. Do that on both sides. This cancels out, and you get x less than or equal to 8. Okay. Bring that down. 8, 9, 10, 7, 6. Just make it easy on yourself. Just go by ones. It's easier. All you're trying to do with this is show what's going on with it. Okay. You don't have to make it hard. Make it simple. X is less than or equal to 8. My arrow's going that. And my variable's on the left. That's where I want it. So, does it include 8? Yes, it includes 8. So I need a closed circle. And then my arrow to the left is going this way. And then you can plug these in to see, do those satisfy the condition? And it does, so we're good. Coming back over here. X divided by 2. Multiply by 2. Multiply by 2. This crosses out. Leaves me just x. Leaves me 8. And then I'm going to take these and I'm going to flip it. Now I didn't leave myself much room there, so I'm going to do it up here. So x and 8. And then when I do that, I flip my inequality. Okay? There we go. So x is less than 8. So 8, 9, 10, 7, 6. And does it include it? No, so it's open circle. And my arrow's pointing to the left. So there we go. All right, so guys, this stuff right here, not hard. Don't overcomplicate it. It's not that hard. This is where if we're going to make a mistake, here's where we'll make our mistakes. All right, so we have a rule for this. Our rule is when you multiply or divide both sides of an inequality by a negative, you must flip the inequality. All right. So here's how you can look at this. If I have 2 less than 4, that's a true statement. 2 is less than 4. But when I multiply both sides by a negative number, 2 times negative 1, well, that becomes negative 2. And 4 times negative 1 becomes negative 4. Now, normally we would just leave the inequality and we would see if that's a true statement. But when I read this, negative 2 is less than negative 4, that is not a true statement. Remember, the further left you go on the number line, the smaller the numbers go. Well, this is further left than this is. Okay, so this is actually a bigger number than this. So when we multiply both of these sides here, we have to take and flip this inequality. So this went from here, and it should have been here in order to make this a true statement. Negative 2 is greater than negative 4. And if you were to put this on the number line, right, it would make sense. So let's say this is 0, negative 1, negative 2, negative 3, negative 4. Well, again, the further left you go, the smaller the number. 0, negative 1, negative 2, oh, there's negative 2, negative 3, negative 4. Well, this is further to the left on the number line, therefore, this is smaller than this, or this is greater than this. And that's all that we're doing here. Okay, so again, we're going to reread the rule here. When you multiply or divide both sides of an inequality by a negative, you must flip the inequality. So when we multiply or divide both sides by a negative number, we flip that inequality. All right, so we're going to put this into practice. All right, here we go. Negative 2x is greater than 4. So here, it's really the same thing. We draw our line. This is being multiplied times that variable. So we do the opposite, which is divide. So we're going to divide by negative 2. But what we do to one side, we must do to the other. Divide by negative 2. And this right here crosses out. But look at what we did. We divided both sides by a negative number. So we're going to be flipping that inequality. So those cross out. Bring down your x. 4 divided by negative 2 gets me negative 2. And when I bring this down, I'm going to flip that inequality. Now look, this number went from being positive to negative. All right? That's a pretty good indication that, oh, I might have something going on here that I need to deal with. But the key here is that you multiplied or divide by a negative number. So you had to flip that inequality. So x is less than negative 2. So I'm going to start right here, negative 2. Well, if I go to the right, negative 1. If I go to the left, negative 3. All right? Again, there's our number line to kind of give us that illustration about what's going on. And I'm going to say close or open circle because there's no line under it. So open circle. And then x is less than negative 2. Again, we can use a little trick to tell us which way that arrow goes. And here we go. We know it goes this way. It's not terribly complicated, but if you don't memorize this rule, you will mess it up. So memorize that rule. All right, same thing here. Now on this one, they have negative x over 2 is less than or equal to 4. Did I do that right? Yep, okay. So here we have this negative and it's just kind of hanging out off to the side, but we know it goes with this. And this whole fraction is negative, so you can float this to the top or you can float it to the bottom. It doesn't really matter. In this case, I would send it with this number so that when I'm done, my variable is a positive number or positive variable. So I'm going to take this, I'm going to send it down there with that negative 2. Now, in order to get rid of this, okay, this is division, so you're going to use the opposite operation, so you're going to multiply by a negative 2. So here, multiply both sides by a negative 2. These cancel out, and you bring down the x. 4 times negative 2 becomes negative 8. And again, I multiplied by a negative on both sides, so what do I do with the inequality? I flip it. So now my inequality here goes from less than or equal to greater than or equal to. Greater than or equal to. And I'm going to take this number, I'm going to plug it in here. Negative 8. To the right, the numbers get bigger. Negative 7. To the left, numbers get smaller. And now all I have to do is graph it. So x is greater than or equal to, So it's equal to, so it includes the closed-in circle. To the right is my arrow. Kind of tells me which one. So everything greater than that is to the right. It's not bad. All right. Just a couple more. 8 is greater than negative 4x. All right, so this one. Same process. Draw your line. Negative 4x times x. Divide negative 4. Divide by negative 4. This cancels out. This becomes negative 2. This leaves me x. I flip the inequality because I've divided by a negative number on both sides. But now look, your variable's over on the right. I don't want my variable on the right. It makes it harder for me to graph. So I'm going to take that and I'm going to switch it just like I did on the other ones. And when I do, I'm going to flip the inequality again. And that's the reason that I did this. So here, we're going to take this inequality and I'm going to move it up here just so that you can see, okay? I'm going to flip them, x, negative 2, and then I'm going to change that inequality again because it was on the way. So here becomes here. So x is greater than negative 2. All right, graph it. Negative 2, negative 1, negative 3. Open circle because there's no line underneath it. And then to the right. Okay. To the right. X is greater than negative 2. So everything that's greater than that is a solution to that. All right, so here's the other one that you're going to see. Negative x is greater than or equal to 4. Remember what's in front of that x. There's always, if there's no number there, there's always a 1. There's always a 1. All right, so there's a couple different ways that you can do this, but I'm going to continue on with what we've been doing. Since this is negative 1 times x, we're just going to divide by negative 1. Divide by negative 1. Divide by negative 1. This cancels out, and you have x, negative 4, and because you multiply or divide by a negative number, you flip the inequality. Graph it. It equals it. Negative 4, negative 3, negative 5. And a little trick to tell me which way to send the arrow. Here, less than. All right, guys, I know this was a lot of problems, but each one you're going to see again. This gives you a problem that you can go back and go, okay, well, I know I've seen one like that before, and you can go back and you can look at it and say, oh, that's what it looks like. That's what it should look like when I do it. Okay, so, and I kept the numbers easy because it's more about the process than it is the numbers. All right, so just because you have different numbers, it's still the same process. If you have any problems, you need anything, come let me know.